According to the leave plan of room, experts, it will take what seems like an eternity before that attempt becomes a reality using our new 1 billion toy. If everything goes according to plan, the trip to Proxima should take about 20 years, so it makes sense that it will be a very long time before we can acknowledge whether there is unquestionably life on that planet. The long-standing question of whether we are really alone in this universe still persists. The James Webb Telescope has discovered a few remarkably human-like objects far from Earth that bring us closer to the solution. Our quest for life beyond our planet has been so intense throughout human history that there are a plethora of media and theories about it. Our wonder about our position and loneliness in the universe has remained constant, as if we are wired to constantly seek out friends no matter how alien-like they may be. We may be getting closer to the answers we actually need, but are they the answers we are looking for, or are they much more unexpected? Come along with us as we investigate the most recent findings in the realms of universes and planets in an attempt to find something we might not be prepared to see. When the James Webb Space Telescope JWST was scheduled to launch in 2021, a very intriguing hypothetical question regarding the extent of human development was raised. The question was whether our telescopes could eventually recognize artificial light on another planet like Proxima B, the closest exoplanet to Earth. Proxima B is approximately 4.25 light years away, and it was hypothesized to be neatly locked with an exceptionally bright day side and a dark night side. Similar to our moon, this could be the most important discovery in history. According to very distant experts, in 2024, the James Webb Telescope did exactly that, using its higher sensitivity and more advanced range of capabilities. JWST could have detected the lights we were looking for, potentially propelling us into a new era of human progress. Taking everything into consideration, let's explore the universe of planets and exoplanets to understand how this was even possible. Advanced civilization on Proxima B was able to transfer power from the day side to the night side using photovoltaic cells that generate power from starlight, so that the large-scale presence of day-side solar chargers could be detected with future telescopes. The mission of James Webb exam from the start, Proxima Bs have kept secret since gaining consciousness. Humanity has attempted to find answers to the following natural yet profoundly unsettling questions. What are we? Where do we come from? And where do we go in this age of extraordinary technological advancement? One wonders if we are any closer to finding the answers. A philosopher might argue that our comprehension of the universe and ourselves is still at zero, while an astronom would be happy to reveal the most recent findings about the cosmos using cutting-edge instruments, although the general public frequently ignores these instruments. They are a testament to human progress because we now have the world at our fingertips, and the time has come to bring the universe closer. Scientists and space experts have studied one such method of exploration through innovation, and we came up with a specific plan that has already produced new discoveries like what might be light on a distant planet. Yes, we are referring to the James Webb Space Telescope, which is the pinnacle of human endeavors to investigate space and find the answers to the age-old problems of whether we are alone in the universe. What is the starting point and the ending point? These inquiries have just recently been addressed by this infrared astronomy instrument. Even though the James Webb Space Telescope is still in its infancy, it has already shown off its enormous potential. However, before learning more, you might be wondering what Proxima is. Proxima Centauri B, also known as just Proxima B, is a member of the Alpha Centauri star system and is classified as its super-Earth exoplanet. These super-Earths are unique and can be made of gas rock or a combination of the two. Proxima B is a rocky super exoplanet, and its discovery was groundbreaking because it orbits in the habitable zone of its star, increasing the possibility of liquid water and possibly life. The first evidence of an exoplanet was discovered as early as 1917 but received little attention at the time. The first confirmed exoplanet discovery was made in 1992, which shocked scientists. As of April 1, 2024, there are 5,653 confirmed exoplanets in 461 planetary systems, including 896 systems with multiple planets. These findings demonstrate the enormous diversity of our galaxy's planetary systems. The smallest and most prevalent kind of star in the Milky Way is N-type star, sometimes referred to as a red dwarf, which Proxima B orbits since many of their planets are in the habitable zone. Red dwarfs are interesting study subjects, even if it can be difficult to locate planets surrounding them due to their relative dimness and far lower light output than the Sun. Intriguingly, Proxima B has a mass of roughly 1.07 times out of Earth and completes one circuit of its star in just 11 to Earth days, which is significantly shorter than Earth's 365.25 day year. This quick orbit is caused by Proxima B's relative proximity to its star, which is only 0.045 to 0.056 astronomical units away. For comparison, the distance between Earth and the Sun is $1 since its announcement in 2016. The discovery of Proxima B has drawn interest from both astronomers and space enthusiasts. Its closeness to our solar system, just 4.25 light years away, is a key factor in this fascination. Being the closest known exoplanet to Earth, Proxima B is a prime prospect for further research. Its special qualities further increase its allure. Its star, Proxima, emits only about 1.6% of the Sun's luminosity, with over 85% of its energy in the form of infrared radiation. This results in a dim environment for Proxima B, with only 5 to 6% of the sunlight we receive on Earth. Despite this, its location within the habitable zone raises questions about its potential for hosting life. It is a direct blip in this manner. Why Proxima B, our nearest acknowledged star, is high up on the priority list right now. It is similarly a piece of the triple star structure called Alpha Centauri, or despite Proxima exceptionally low brightness, the actual structure appears as one of the brightest celestial bodies in the sky, behind only Sirius and Canopus. The most fascinating thing about Proxima Centauri is that it could be habitable since it falls within the habitable zone. The possibilities surrounding the star are endless, and as such, astronomers have taken on the mission to explore the depths and limitations of its potential. This is where the James Webb Space Telescope, one of the JWST four main goals, is to search for life from the first stars and galaxies to originate in the cosmos following the Big Bang. As the JWST continues its investigation of this exoplanet, we get closer to accomplishing these goals. 2, to concentrate on galaxy formation and evolution. 3, to comprehend star and planet formation, and 4, to study planetary systems and the origins of life, from looking for exoplanets to seeking extraterrestrial life and to search for extraterrestrial intelligence. One might ask, what exactly is SETI? Humans have always been an inquisitive species, exploring, experimenting, and observing everything around us, so it's not surprising that a mission like SETI's search for extraterrestrial intelligence emerged on Such a large-scale imagined humanity is engaged in a massive cosmic endeavor CI, which is essentially the highest stakes game of hide and seek in the world. Our planet is the seeker and the wide universe is the seemingly limitless. Hiding place scientists at SEI are like modern-day Sherlocks listening to radio wave and trying to find that elusive signal from another world. This cosmic investigation started in the 1960s when Frank Drake, a pioneering scientist, pointed a radio telescope at two sun-like stars and listened. His efforts led to the creation of the famous Drake equation, a formula that estimates the number of civilizations in the universe. Fast forward to today, and SETI has evolved from a backyard science project to an interstellar mission. Scientists use a variety of instruments from the Allen telescope array to the OSO telescope before it collapsed to a set of dishes that resemble futuristic crop circles, with the aim of detecting that one particular signal, a blip or murmur that connects us to another universe. The WOW signal, when a signal known as WOW was identified in 1977, it was a radio burst so exact that the astronomer who found it wrote WOW in the data margins. It's unclear if this was alien life phoning home, but it increased enthusiasm to maintain our massive radio dishes. With the development of technology, listening to SETI's new frontier is no longer sufficient on its own. This new phase of exploration looks for technological indicators of modern civilizations, such as city lights or solar panels covering an exoplanet beaming under an alien. Sunday, the goal is to find pollution or artificial light in faraway atmospheres. Together, they form a tag-team effort that is tightly aligned with the JWST mission. The telescope's advanced infrared capabilities could help SEI identify these Tekken signals. Despite its potential, the quest for extraterrestrial intelligence confronts many difficulties. The JWST detects planets and listens for indications of intelligence, even though space is unfathomably large and signals are as elusive as finding a needle in an intergalactic haystack. And because of the limitations imposed by the speed of light, signals from civilizations millions of light years away would take Ian to reach us. The search goes on despite the odds, because of the potential that one day we might learn that we are not alone in the grand cosmic stage, a revelation that would change the course of history. The implications of this discovery are both exciting and terrifying. There is still much to learn, but the most unsettling part is the sheer number of possibilities. Let's examine the specifics and consider what this means for humanity. Recent findings using the JWST suggest that Proxima B may have artificial lights on its dark side. However, what does this really mean? Does it indicate the presence of a civilization advanced enough to use tools like ours? Have we found companions? Or are we still alone in the universe?